So my name is Marian Rusnak, and I'm going to talk about our experience with Express apps on AWS Lambda. Let me first ask you, who has heard about AWS Lambda? Put your hands up. Oh, nice. And who has actually deployed some code on AWS Lambda? Nice. It's a good audience. Who has actually deployed Express apps on AWS Lambda? All right, so it's going to be something new for most of the audience. So I work at Oath. Anybody heard about Oath? All right. So it's pretty big company. It's AOL and Yahoo together in one company, owned by Verizon, which is a big American telecommunications operator. And we own a media like TechCrunch, which is the most followed publication on Twitter. So we own media and we own some advertising platforms, which is what I do. So I work for advertising system for creating ads. So advertisers can create ads and promote their brands, and that's. Here are some stats about the company. You can have a read later. This is the agenda for today. I'm gonna talk a little bit about how we got to AWS Lambda, and then about technology stack we use there, and what are the limitations and obstacles we had to cross. So back in 2016, I think, the company decided to move to AWS. They decided to move from our own data centers to the public cloud, and at the same time, they also they wanted to limit costs. They wanted to reduce costs because company had many acquisitions, and there were systems that were not being used, and they were just aware of the costs, and they wanted to reduce them. So, and that was the time when we wanted to develop the new API. It was new flexible system to support like any kinds of ads, and improved development of templates, and etc. It's not that important for the talk, but important is that we didn't expect high load, because the API would be integrated into internal systems, and not many people would use it. But it would be just backbones for other internal systems. So we are talking about like hundreds or thousands of requests a day, let's say. And we heard about Lambda, AWS Lambda, that it's we heard about Lambda functions, that we can pay only when it runs. So it's really good for us because we can have low costs, and that we have no server management. So, and yeah, you are familiar with Lambda functions, you've heard about. Maybe some of you don't know how exactly it looks like. So for those of you, let me just illustrate. It really is a function. You can code it in an online editor directly, or you can upload the zip if you have multiple files, so you can zip it up and upload. And so, as I said, you only pay for it when it runs, so you don't need to, you avoid having virtual machines which has low utilization, and you can upload the zip. And Lambda functions, they have free tier, which doesn't expire after 12 months, and it offers you 1 million requests a month and 400,000 seconds of execution. Which really, if we are looking at 1,000 requests a day for our API, we would be okay with this free tier. And the benefit that we don't need to manage servers, we don't need to monitor them, and it's just automatic. It just our code just runs somewhere in the cloud. So this really was a benefit for us, and we decided to go for it. But hang on, how are we going to develop our code if it's like we would develop it in an online editor, or we would be uploading zip files? we couldn't do that. So we found these great tools that can help us in development. One of them is AWS Serverless Express library, which translates Lambda events to Express to the request that Express app understands. So it's really like a wrapper around. It wraps your Express app and do its magic. So this is like a boilerplate code, and you can see that it wraps your app and then creates a proxy to the Lambda event, and you can deploy this to Lambda. You can upload this to Lambda. What this gives us is that we can develop our applications as we were used to, like normal Express applications with the routes and everything that we are used to, and it can be in one project. So it's really simple development. The drawback is that we would have a larger function, but the API is not that large for that it cannot be deployed there. So it was okay for us because the benefit was that we would have a simpler development. And another thing that we used is Claudia.js, which prevents us from just uploading zip files to Lambda. So by running simple commands, we can deploy our code. Claudia.js is a command line tool which you can use to even generate the boilerplate code, which I showed you before for this AWS Serverless Express. This is this first command, and this command, the create command, it will create all the entities in AWS for you. So you just run this simple command, and all the Lambda function is created, the policies that it needs, roles and etc. It creates everything you need for your function to run. And then when you do some development, you just run Claudia update, and it just uploads the changes to AWS. So here's a link to the tutorial, so you can have a read later. And as most of the applications do, we needed a database. So as SQL is like not cool anymore, so we decided to use NoSQL. The obvious choice was DynamoDB because it's available in AWS. So it's a NoSQL database from Amazon. It offers fair amount of storage for free, and you pay for storage, you pay for requests, but you have, for example, 200 million requests free a month. So we would be okay with that. We would not pay anything for our not many requests for our API. But we were using this DynamoDB, and so the querying was not flexible with this, with DynamoDB, but it was okay. We didn't have any complex queries, but the most important part here is that it has a 400 kilobytes maximum item size, which for us it was really a limit because we wanted to store large data in a JSON there. So also there is a 1 megabyte limit on the retrieve data. So if you want to retrieve more data, you need to poll it to send you more data. So we were not happy with that, and we decided to switch to MySQL. And believe me or not, it still works. It's proven technology. Especially what we found is that there is a JSON data type in version 5.7, which was really helpful for us because we needed to migrate. So we could leverage the JSON data type, and the migration was quite smooth because of that. And important thing, it's available in RDS, so we don't need to it's like a hosted version of the database. We don't need to manage servers, and yeah, it's just there. So yeah. One more thing which our application, which our API needed, is to offer file uploads, and we store those files in S3, which is also obvious choice for AWS. It's good. It's relatively cheap. It stores files like it's a key value storage basically. But those, if the keys share the same prefix, they form directories. So yeah, it's good. Here's some pricing. It's really not expensive. However, we realized that there is a file upload limit. There is a maximum payload limit in the API gateway, which sits in front of the Lambda. So you can only send 10 megabytes in one request maximum, and also Lambda can only process up to 6 megabytes. So the request to Lambda can only have 6 megabytes. So this was a limit to us because we wanted to support uploads of larger files. And there is a feature in S3. It's called pre-signed uploads, and it allows you to generate the key for a user to go and upload a file directly to S3. So here I wanted to illustrate this. So your API creates an endpoint. So for example, my pre-signed endpoint, a user hits that, and it gets returned the URL to the upload endpoint. So user hits your API, he gets returned the URL to the upload, and then he uploads the file to that URL. Well, I'm talking the user, but it can be a client, it can be a CLI. So so CLI hits the pre-sign upload first, and then it gets the return the URL to upload the file, and then it uploads the file to that URL. So yeah, and so we had our API, and we wanted to improve the local development because we used S3, and S3 is available in AWS, but for local development, we found a library. It's called S3, it's called S3 Server. I don't know how to pronounce. Server. Yeah, Server. So it has a small set of S3 API mocked, and it's basically a local S3 kind of mocked version. So yeah, we use that for tests. And we use MySQL in Docker. So when tests run, they start up the Docker container with MySQL, then it shuts down after the tests pass. And we have also some other services just mocked, just simple routes for local development. Yeah. So our API was running for some time in AWS, and we noticed that the API sometimes takes too long to respond. So we were investigating that, and we realized that Lambda is shut down when it's idle for around 15 minutes. So there is a way to reduce that. So we created jobs that every 10 minutes makes a request to the API to keep the container running and prevent it being shut down. This doesn't mean that we pay for it, because we pay for it only when it runs. But to prevent it being shut down, so it's always warm, so so we don't have the additional latency. Yeah, we have jobs that pulse the API every 10 minutes, and then also we created CloudWatch events, which it's also like a job, but directly in AWS. So it's just an internal request. We do that every 5 minutes. And important thing to note is that even though we did that, we hit the API every 10 minutes to keep it warm. You can never avoid Lambda from being shut down at all, like completely, right? Because AWS sometimes it randomly shuts down the containers, but this is just to like reduce these shutdowns. So that's what we did. And sometimes, because we hosted, for example, Swagger UI in Lambda, we noticed that when we were requesting static assets, the Lambda was taking too long to respond still, even though it was warm. So Lambda is not good for serving apps with many subsequent requests, because then Lambda thinks that, oh, the load is high, so AWS will try to spin up like more and more Lambdas. So what we did is we moved static assets to S3, and this drastically improved response time. And only the variable parts we have in the API and static assets are in S3. So yeah, we wanted to secure, for example, database passwords. So that we don't store it in the source code, and we used KMS for that. It's another AWS service. It's just you hit an JavaScript API, and it returns you the unencrypted value. So every time we deploy a Lambda function, we set the environment variables, which are encrypted values. And then when Lambda starts, we decrypt that value and just store the decrypted value in memory, so it's not anywhere in the code. It's alright service. However, we realized that our API is sometimes timing out, and the API gateway has execution timeout of 30 seconds, so you can never run your request for more than 30 seconds. And we realized that it was sometimes timing out because of the KMS, the decryption. So we were, for example, decrypting 3 different keys, and it just took more than 30 seconds. Yeah, we raised a couple of tickets with AWS, and then it just resolves by itself. We didn't have any problems in the recent months, so I don't know, but yeah, I just wanted to tell you that. We wanted to add video processing for uploaded files, and that's why we needed a binary for video processing. So we didn't want to reinvent the wheel, just use an existing library for video processing. But we realized that there is a limitation on the package size of the Lambda. So when we added the binary, we just got an error that, oh, your package is too large to upload, too large to deploy. So there is a 50 megabytes deployment limit, deployment package limit to when you upload directly to Lambda. There is an option to deploy via S3, so you upload your sources to S3, and then in AWS it somehow just deploys it to Lambda. And that limit is 250 megabytes. So yeah, we are under that. Thing to note, also 75 gigabyte is limit for total size of packages in one region, which like so total size of the historical packages. So sometimes you need to delete that. And pretty recently, there was a team which got to me that we are getting the 413 errors when hitting your API. It's actually a different API that I'm talking about today, but so we have a couple of APIs in Lambda, but yeah, they said they were getting 413 errors, and I googled it, and there is a URL size limit, so they were hitting that. That URL size URL can be maximum of 8 kilobytes. You will probably not run into this issue. It's specific to our API, but it's just interesting to know that yeah, there's a 8 kilobytes URL size limit. And yeah, just to summarize all the limitations I talked about throughout the talk is that Lambda shuts down when it's idle, so you need to keep it warm by just polling it, and there's a 30-second API gateway execution timeout, so try not to run your request for too long. There's a maximum payload of 10 megabytes, and well, actually we can say it's 6 megabytes, the maximum request size, and deployment package can be 50 megabytes or 250 megabytes if you upload via S3. 8 kilobytes URL size limit, and Dynamo has silly limits of 400 kilobytes per item size and 1 megabyte on the retrieved data. And just to talk about the result from our side is that we really are happy with Lambda because we don't need to manage servers. So we just deploy code and it just runs, scales automatically. We don't need to update, do the updates of the VMs and stuff like that. It's really good. We don't need to do ops work. And by using Express and the AWS serverless Express, it prevents us from being logged in to AWS because yeah, if we decide to, we can just move it somewhere else because it's just Express app. And we also use MySQL, so yeah, we can just migrate to something else. We don't use Dynamo, and it's really quite cost-effective solution for our not heavy traffic API. I checked the how much we spend, and it's like for Lambda we are in the free tier, and we really only pay for S3. And it's like, it's in it's like $1 a month or something like that. And yeah, good to know. It's relational database might often be a better option than NoSQL. So yeah, just consider it. And thank you very much.